So if you have a construct of leadership having 10 items, okay, and there were 10 items that we had. Now, because you have more items, the requirement for data goes up because the software has to compute more and more parameters in order to estimate this model. So one of the recommendations is, it is a very simple recommendation. So you have item 1, item 2, item 3, item 4, item 5, item 6, item 7, item 8, item 9, and item 10. So the recommendation is that you test the alpha, Cronbach's alpha, and you have already estimated this model. So you will get an estimate of composite reliability, and both of them are greater than 0.70. That means items show good inter-item consistency. In that case, instead of having 3 separate items, you create one average I for EMP. Okay, so how do you compute average? You can simply say I1 plus I2 plus I3 divided by 3. This becomes your, you can call this as average EMP. Similarly, you have tested the alpha and CR for TO, so you can compute average TO, which is I4 plus I5 plus I6 divided by 3. Here there were 4 items actually, so it should be divided by 4, and you create one item which you call average TO, and similarly you have average LEH. So instead of 10 items now, you can model one latent factor leadership, okay, having 3 items. Okay, so your sample size, instead of estimating 10 items and their parameters, associated parameters, what you are left to estimate is only 3 items and their parameters. So this is called as parcel. These are called as parcels. Okay, this is called as a parceling approach. And what you have done is, if you have, this is total disaggregated. That means if you go, let us go back to this paper. So one is when you have the original model with all these 10 or 9 items, what you should do is partial disaggregation. So you do aggregate, you create parcel 1, parcel 2, and parcel 3. Well, one possibility is also you can aggregate all 10 into one item, okay, which is called as total aggregation. But then if you read this paper, the suggestion of the authors is that this is the most advisable thing to do, which is called as partial disaggregation model. And this will make your models simpler, reduce the sample size requirement, because the software will have to compute lesser parameters, and you can estimate your data and reach your results well, right? And they show that this is a very this is quite a used method in OB and HRM and social sciences kind of a thing. So if you have very big data or very big constructs, you can use the parceling approach to improve the fit of your models to reduce the sample size required.